So you can see that there is an installation here. Click to install. Here is an option for a protocol. Can choose. You can click to add. But it's gone now. This is something we rarely use. But for the early, we will still install the protocol station manually. Because there is only one protocol station in the world now. No need to install. Because a network device is bought by default. Just to communicate. You can only choose this one if you want to communicate. Because all network devices only support TCP/IP. So now, by default, we also don't need to install any protocol. The difference between v4 and v6 is that the first point is the address space. IPv4 is 32-bit. IPv6 is 128 bits. IPv6 headers are more compact. Takes up less space. Implemented more functions. Made a comprehensive expansion on the entire IPv4. In fact, the first problem to be solved is the number of addresses. In the future, if it can fully migrate to the state of IPv6. In fact, there is no distinction between public and private networks. This concept we will discuss next. Then will be a lot easier than we are now. This is only from the address direction. Second, due to the overall scalability of IPv6. It's in a lot of future features. More support than IPv4. Including IPv6+ in recent years. SRv6. This is the future trend. Due to the rapid advancement of IPv6 technology. So in recent years, IPv6 has been mentioned more and more. But in fact IPv6 has been around for a long time. But in recent years, the demand for it has become more and more strong. The above is to test the TCP/IP protocol station. When you have installed TCP/IPv4, you go to ping 127. No matter which address on the 127 network segment you are pinging. Ping from point 1 all the way back. Can be pinged. It tests the underlying protocol. So you will find, although the ABC class address can now be configured, but actually there aren't that many addresses available. Class A addresses are available from 1 to 126. You need to remember this. Okay. Let's go on. We have already divided the three types of ABC addresses. Well, I now have a new question. If I were to now have access to all the devices in the world, assign an address. According to reason, everyone must have an IP. Because if there is no IP, data packets cannot be encapsulated. Can't get online. Internet access with IP. Every device that wants to access the internet must have an IP. Then please. These IP addresses we now call. Is it enough to give each person one? Okay. Definitely not enough. First we need to know. The IP address is 32 bits in total. 32 bits have two variations for each bit. A total of about 4.294 billion changes. Then think about it. Is it enough to distribute to the whole world? We don't have only one mobile phone to surf the internet now. Generally speaking. Working. At least one laptop for office. Play games at home with a desktop computer. You have a computer. A cell phone. And a tablet. Each of your parents has a cell phone. Suppose there are 5 people in a family. Will occupy almost 10 addresses. Including at home and now. Smart speakers or smart sweeping robots. Or the TV can also be connected to the internet. All these addresses add up. I believe you can imagine how many. For netizens all over the world. One address per person is definitely not enough. According to our logic. Wouldn't this collapse? If you want to go online, you need an address. Not enough addresses. How did you get on the internet? So there must be a way to fix it. That for the entire address design we envisage. Because there may not be enough addresses. Therefore, in the overall address classification, we have divided into two categories. They are called private address and public address respectively. That is, based on application, split into public and private networks. So let's first talk about the public address. We want to communicate on the internet. All addresses under the public network when communicating must be unique. For example, your company is now running a business. Then your company is on the whole network. Is the only device that needs to be able to locate you. Your company has an export facility. Like Google. Google has a server. Then you want to access Google server. It can't be said that the Google server has a duplicate IP address with another place. When you visit, who among them was visited? Also unknown. So we face the public network. We want all addresses. Must be unique. The public address has such uniqueness. I can access the entire network. That is, in the internet as a whole. I can only locate your device. Its uniqueness is based on worldwide uniqueness. That is to say, worldwide. It is guaranteed to be unique. But usually, you have to pay for this stuff. You need to spend money to find the operator to handle the corresponding service. Then the corresponding public address will be given to you. So we will know. Due to too few addresses. So it is impossible to guarantee. Every device in the world. Every interface. Use a public network. Definitely not enough. Suppose your company has 100 people. Need to apply for 100 official website addresses. For the time being. Let's not say whether the address is enough or not. The cost is already very high. Because it costs money. So, now we are going online. What each end user actually uses. Not a real public address. Instead use a private address. It is actually from the overall address space. Cut out a small piece. As a private address. Private address and public address are relative. It's not the only. This means that all network-wide can be used arbitrarily. It is free. And you don't need to apply. It is reusable. This is called a private address. Now above this is the operator. Below is the carrier's network. Services it provides us with access to. There are also many devices in the operator. And they are also connected. The address they use is the public address. Because operators want to provide mutual access services around the world. That is to say, all forwarding addresses on the public internet must be determined. Can uniquely locate the next device. Because you have to keep querying the next device. Forward. It is absolutely impossible to appear in the middle. Two addresses are the same. Certainly. It's not absolute. Later you will find out. It's not as simple as what we're learning now. But you can understand this now. Public network. The operator's network is the public address. Of course it also has a private network. But the specific operation and enterprise network are not a set of operation model. Therefore,